AC, or alternating current, describes a flow of charge that changes periodically. This also leads to the voltage level reversing with the current. This can be shown easily with an analogy, in which current is shown as water. As the crank moves the piston, the direction in which the water or current is flowing changes. One full rotation of the crank moves the piston from fully extended to retracted and then back to fully extended. AC is typically used to deliver power to large-scale buildings such as houses, office buildings, and manufacturing plants. AC is generally generated using an alternator. The way it does this is that a loop of wire is rotated inside of a magnetic field, and thanks to Lenz's law, which states that when electrons interact with a magnetic field, they experience a force and therefore produce an electric field. The effect of an alternator can be shown as a point rotating around a circle. The effect of this motion can be displayed as a sine wave. In the example shown, you can see that much like the water analogy, one full rotation of the circle shows all values from minimum to maximum and then back to minimum. The equation for an AC sine wave can be shown as Vt is equal to d plus a sine 2 pi ft plus phi, where Vt is the voltage as a function of time t, d is the DC offset, a is the amplitude, frequency is shown as f, phi is the phase shift. Amplitude is the maximum distance the wave reaches from zero. This is called the peak as well. To find the peak-to-peak value of a wave, the amplitude is doubled. As seen in the examples, a higher amplitude leads to a higher Y reading. Frequency is shown as f, and is how many times the waveform occurs in 1 second. As seen in the examples, the higher the frequency, the more waveforms in the same time period. The period of a wave is equal to 1 over the frequency. The period is how long a single waveform is. It can be measured from any point, such as peak to peak or trough to trough. Phi is the phase shift, which dictates how far the waveform is shifted with respect to time. When both waves have the same phase, they are denoted as in phase. This brings a conclusion to the small glimpse of the truly riveting world of AC sine waves.